All right, y'all, this is the soil battery proof of concept video. Let's get into it. So first and foremost, I've got my multimeter. We're gonna use this to measure the direct current voltage, right, DC voltage. And then we've got our materials over here. So first and foremost, we've got some healthy soil, lots of compost, lots of organic material, right? Minerals, different stuff, okay? But we have different stuff here that basically used to start fires. So first and foremost, we've got carbon in the form of lump charcoal. And some of this was broken down into a powder, mixed into the soil, and then some of it was kept in chunks, okay? But this shit starts fires. Then we've got magnesium. There's some magnesium shavings, which I have not put in the soil. What we're using today are magnesium fire starter rods, okay? So you've got like a little fire starter kit right here, right? But fire is the idea here. But specific materials, okay? Carbon and magnesium. And we're doing this like for a very specific reason, okay? Trying to build soil and grow plants. All right, now let's come over here. Let me get a nice wide shot so you can see if we get some voltage. Oh, what do you know? Shit, 500, 700. Wow, okay, 0.7, 6 over here, 0.7, because we got some magnesium rods in the earth, okay? So how does this work, right? Dissimilar metals that are conductive. Magnesium, carbon. Carbon's not necessarily a metal, but it's dissimilar and it conducts electricity, right? So that's how you get a battery. Dissimilar metals that are conductive, right? Awesome. So we're generating electrons. And that's the proof. All right, so now how is this relevant to plants and soil? So let's jump right up here and let's jump into the chemistry. So we have human blood. This is heme, which is used to make hemoglobin, okay? So we've got an iron atom in the heme molecule, and then it makes hemoglobin, right, when it all comes together, like chains of heme iron. Okay, and this is used to transport oxygen in the human body. And here we have plant chlorophyll. It's practically identical, except for this carbon chain down here. It's like a, really long carbon chain down here. But then also we have this magnesium atom in the chlorophyll molecule. So what is this doing? This isn't transporting oxygen. This is used to build chloroplasts. So heme is used to build hemoglobin. Chlorophyll is used to build chloroplasts, and the chloroplasts capture photons and use it to make sugar. So photons are like light particles, right? We got light particles all over the place coming off the screen, going into the phone, right? Well, this is what allows plants to photosynthesize, okay? Now, this structure is critical. We're going to look into why. We need magnesium ions. Okay, magnesium ion is a positively charged metal ion that plays essential roles in various biological processes. Okay, photosynthesis, right? Let's go ahead and move the camera a little bit. It's an awkward position, but let's get a visual of what's actually happening here. Okay, so we have a magnesium atom right here, and then we have a magnesium ion. So you can see the ion has 2 electron shells, and the atom, the regular magnesium atom, has 3. It has 2 additional electrons in the valence electron shell. And what the plant needs to produce chlorophyll are magnesium ions. So those 2 electrons have basically broken off, right? Creating this positive charge, right? We're donating electrons, right? So down here we have a different explanation of it, right? 12 electrons in the cloud, 12 protons in the nucleus, right? The center part, right down here, 10 electrons in the cloud with a complete, right, valence electron shell, 12 protons in the nucleus, okay? And that's relevant because that's how these nitrogen atoms are actually able to bind to the magnesium. These nitrogen atoms cannot bind to the magnesium if it's not an ion. So it needs to be a magnesium ion. So when we run electricity through the system, we create a magnesium ion, allowing the plant to produce chlorophyll. but then we also create these additional electrons, these two additional electrons that can stimulate other biological processes either in the plant or in the soil. So the soil microbes can use those additional electrons as well. And we're not using salt fertilizers. Why is that relevant? Salt fertilizers break down the soil. They cause the carbon to burn up and turn into gas, basically. So the soil and the carbon layer gets depleted, okay? This is essentially a slow release fertilizer for magnesium specifically. That's all it is. And what we're doing is we're creating two byproducts, magnesium ions and electrons. One goes to the plant, one goes to the soil. That's how we keep the plants and the soil growing together, not depleting the soil. So magnesium metal is actually, critical as a fertilizer in soil systems if you're trying to build up the carbon layer, because everyone talks about shit like no-till farming, and that's not enough. There basically needs to be some source of electricity in order to actually keep the soil intact and to keep the carbon from burning off, because microbes can do that. That's why compost piles shrink. It's because those microbes are consuming everything and releasing carbon gas, and then the compost pile just shrinks and shrinks and shrinks, right? And then also we just go ahead and deplete our soils through tilling and all of these other things. So we are creating a soil battery that gives plants the fundamental nutrients that they need, right? What fundamentally makes them plants, and then also keeps the soil electrically charged and alive. Incredible. All with materials that start fires. Wild.